Hello, in this video we're going to start with a mostly built up quad. So we have the flight controller, the ESCs and the motors all set up and connected, and there's still a little bit to do. We've got to attach the receiver and probably attach a buzzer too if you have one. But in this video we're mostly going to be looking at how we can set up Betaflight to take it the rest of the way and get it into a flyable state. So starting from the configuration page of Betaflight, this little box here is labeled Mixer, and this refers to when the quadcopter wants to make itself move around, it needs to know what positions the motors are in order to tell which ones should be spun faster or slower. And the default setting for this is quad X, which means 4 motors in an X shape. And for both of the quadcopters that I'm building in this series, they are actually a perfect square. The motors are laid out in a perfect square, so I don't need to change anything here. But let's have a look at some other settings we could have. We could have also a quad plus, which will be like that. We could have a hexacopter, we can have tricopter, and there are quite a number of mixings we could have, octocopter and so on. So if you are using something else, you'll obviously want to choose that. And we can also have a mixing that is still a quadcopter, but it's not a perfect square. For example, a couple of these other quadcopters I have, if we look at these motors, we'll see that, or the positions of where the motors would go, it's not a square, it's more of a flattened rectangle, because this side is shorter than the distance from there to there. And likewise, this one is not a perfect square either. It's sort of, the motors are further apart at the front than they are at the back. So for a case like this, if you don't change anything, you'll still be able to fly them, but they might be a little bit unstable and they probably won't perform as well as they could. So what you can do is you'll need to come into this command line interface and type in a few command lines. But I have actually made a tool which will help you calculate the stuff that you need to type in. So I'll just refer you to the video that I've made about that. Actually, let's just have a quick look at that because it won't take too long. I'm not going to explain all the details of how you will set this up for your quadcopter, but I just wanted to show you in a quick example. So say you have a rectangular kind of shape like that. If you come down the bottom of this page, you'll be able to select one of these, and what you want for Betaflight is going to be this one here, Clean Flight from version 1.10 onwards. And then you'll copy this section of text, and as it says here, remember to also execute save to keep the mixer settings, which means that if we come over here and we go to the CLI tab, oh, is this working? Okay, and just paste it in here. Does it work? Yeah, you'll only see one line there, but if you just hit enter, you should see all of that stuff go in. And then if you type save and hit enter again, it will say rebooting, and then it will take you back here. And when you do that, you lose that nice 3D model display and you end up with this rectangular box instead. But that's okay. And then if you go to configuration, you should see that it now says custom, and it doesn't really have any picture to show you because it's a sort of it's something that it doesn't have a pre-organized picture for. But this is correct if you wanted a custom mixing. But since I actually do not want custom mixing, I'm going to put this back to quad X and save and reboot again. By the way, this little yellow and black marker in the middle is the center of lift, or the center of thrust. And if I just take those constraints away so I can move it, we'll see that it's just the average position of these 4 motor locations. And what that means is that when all the motors are giving the same amount of thrust, it's the equivalent of having a single motor in this position pushing upwards. So what we want to try and do is put the center of mass of the quadcopter here. It doesn't really have to be perfect, but this is a good thing to aim for, because what that will do is it will make it so that all of the motors will be giving an equal amount of thrust to keep the quadcopter in the air. And you can imagine, as an extreme example, say the center of mass, if we put that here, then the 2 front motors would have to work harder than the 2 back motors. And I get a lot of questions asking me about this, and they'll say something like they already have a quadcopter built and they've done exactly what I just said. The center of mass is kind of quite forward. Maybe it's one of these dead cat arrangements like that. They tend to end up with the bulk of their mass of the quad here, and they'll say, how can I set this up so that the flight controller knows that the center of mass is here and not there? And you don't get to do that. The flight controller really has no concept of center of mass anyway. So it's what you should be trying to do is matching the center of mass to the center of thrust, which is going to be here, and it's always going to be there because that's where your motors are. So let's have a look at how you would do that. So when it comes to an actual example like this, that little yellow and black square doesn't help much because it's hard, we can't really see it on here. But it's actually very easy to find the location, and you could do that just by averaging the positions. And the easiest way to average positions is to take any two motors, draw a line between them like that, and I'm just going to have to move this away now, but the halfway point of this line is here, okay? And then you take the other two motors, and it can be any two motors, and then the halfway position of this line will be there. And then we take the halfway point between those two halfway points. So the halfway point between here and here will be about there. And I could have done it this way as well. So I could have done there, halfway points there, and there, halfway points there, and then the halfway point between those two halfway points would be about there. So that's where you want to set things up, and I don't have a battery on here obviously, but you would try and put your battery on there so that when you hold it like this is what I usually do, just sort of, it doesn't feel like it's too heavy or too light in one direction. If you want to get fussy about it, you could put something like that on a flat surface, and this will get you a really precise way to figure out which way or which direction or which location the center of mass is at. But you don't really have to be that precise about it. Okay, so moving right along, now we need to check that the orientation of the sensors is correct. And we'll do that by checking that the movement that we make of the quadcopter matches this 3D model here. So you can see if I can get this all on screen. Can't really see it too well, but you should see that when I pick this up, and I have the front of my quad up there, and when I tip it to the left, the picture on screen tips to the left. If you tip it up, you'll see that there's a green arrow that shows you the front. If this is not at the front, you can actually click this to bring it there. So if I go like this, then if I click reset z-axis, it will put itself like that. So let me just put it there again. Alright, anyway, so whatever you do, whenever you move the quadcopter around in real life, it should match your movements exactly, and you should see that when you lift up the front lifts up the back, back lifts up, and everything moves exactly the way that you're actually moving it. Now, if it does not, it could be that you've put your flight controller board on in a slightly different orientation. Now, the way I've done this is the standard way, which is having this little arrow pointing towards the front. And I like it that way because that lets me plug this plug in from the side, and it's easier than trying to plug it in from the front and so on. And it also means that you don't need to do any extra setup when you come to betaflight. But let's suppose that you did put this, say you put it around 90 degrees around that way, which is probably the most common way that people might change this. You're not going to get the right result on this screen. So what you need to do is come into the configuration page and scroll down a little bit until you see board and sensor alignment. And if you've rotated the flight controller around, you're just keeping it flat but you're rotating it around, that will be a change in yaw as shown by this arrow. So you would need to tell Betaflight that you've changed it by 90 degrees or so. It might actually be minus 90 degrees. Just try 90 or minus 90 and see which one of them matches, but I'll just show you what result you would get from doing that. So I click save and reboot, and now if I go back to the setup page, now if I tip my quadcopter to the left, it actually moved forwards. I tip it to the right, it moves backwards. So this is what you would see if it was wrong. I'm just showing you how the change affects things. So for my case, I'm just going to go straight back here and put that back to 0. The next thing we need to do is calibrate the accelerometer. The accelerometer, if you may recall from one of the other videos, is that sensor that lets the quadcopter know which way is up. So to calibrate this, we need to put it on a level surface and then tell the quadcopter that, okay, this is level. Remember this position because this is level. So if we look at Betaflight and we go to, so on the setup page, you'll see a button called Calibrate Accelerometer. And as you can see, it's not actually level at the moment, even though I have my quad right on the desk is nice, flat and level. The quadcopter actually thinks that it's a little bit tilted to one side. So I'm just going to leave it there and then click Calibrate Accelerometer, and you'll see the quadcopter should straighten up. Doesn't immediately do it, but over a period of a few seconds it should do that. Next, let's take a look at how we can use the Betaflight configurator to control the motors. We can make them spin, and then we'll also see about setting the right communication protocol and then calibrating the ESC. So there's quite a bit to do here, but let's start from the beginning. So in Betaflight, if you look on the configuration tab, you'll see in the upper right ESC motor features, and the first option here is the ESC motor protocol. And does it say something? Oh, there we go. A little bit of info there, but you should remember from one of the earlier videos we have this thing called PWM, which is the way that the flight controller will talk to the ESC to tell it how fast the motor should be spinning. And PWM, the normal PWM that we looked at on the oscilloscope screen, that was the way that worked was that a pulse of 1000 microseconds meant zero throttle, and a pulse of 2000 microseconds meant full throttle. So the upper range, or the upper pulse length, was 2000 microseconds, which is actually quite a long time for a computer, and it meant that we could only get, I think it was 50 updates per second if we have to wait 2000 microseconds for every pulse to finish. So the clever people that develop all this stuff, they came up with a different method, or actually there's quite a lot of different methods now, but the first one that they came up with was one called one-shot 125, and the way this works is that I think it has a 125 microsecond pulse length for zero throttle or full throttle. Actually, I'm not sure which, but the point is that it uses a different pulse length to signify how much throttle should be used at the current time. And this has become very standard these days, so if you first start up Betaflight, you may find that it's actually selected already. But unfortunately, these ESCs that I'm using in this build, these King Kong rather cheap ones, I've found that they are unreliable on one-shot 125, and even though it says in the help or the documentation for those ESCs, so this is the ESC manual, it says it will be automatically detected by the ESC on power up. Users do not need to change any settings. So it looks like they're supposed to be supporting one-shot 125, but in my experience they just don't do it. So that's the reason I have selected PWM for these. They work quite nicely on PWM. And for a beginner's quad, I don't think you'll notice the difference anyway. Now that we have a battery connected, we can go into the Motors tab. And if we scroll down to the bottom here, we'll see this little motor test node description. And this will allow us to manually spin up the motors and check which direction they're going, and check that we have the correct motors in the correct positions. So if you have put propellers on your quadcopter at this point, you're kind of getting hasty. You don't need to do that, and if you did that, you should take them off, because this could be dangerous if the propellers are spinning while it's sitting on the desk in front of you. You don't want that. Anyway, so remove all the propellers and then click on this. This is just like a safety checkbox to say that you are actually intending to do this. And then if we go over here and raise one of these up a little bit, we'll see that that should spin up motor number 1, which is the rear right motor. So this is like this. Motor number 2 should be the front right. Motor number 3 should be the rear left. And then motor number 4 is front left. And we can use the master slider over here to spin them all at the same time. So that's how we can check that we've got the right motor connected to the right ESC pins on there. Next thing that we can do is to check that the directions are correct. And the way I like to do this is to spin the motor and just put a little piece of something in it like this, and you can see from which way it gets hit that which direction the motor is rotating. So this, if I poke this in, so this motor is going counterclockwise, which is correct. So we want it to be sort of going in at the back and in at the front as well. And that probably means that this motor is not correct. So this is number 4. Let me put my little thing in here. Alright, this is also going counterclockwise. And they'll all be going the same way until you change some settings. So it looks like they're all going to be going counterclockwise. And if we just look at this little diagram, have that diagram again. So counterclockwise means that this motor, number 3, and this motor number 2 are already going in the correct direction, and motors number 4 and number 1 will need to be reversed. So there's 2 ways we can do that. One way is to select any 2 of these wires that you have connected to the ESC and just swap them round, and that will cause the motor to go the other way. And you can probably sort of figure out why that is from what we looked at with that funny little homemade brushless motor that I made in one of the earlier videos. It's just, we're just swapping the coils to make it go in a different direction. The other way to do it is in the BLHeli suite software that we saw a little bit before too, but we'll come to that in a minute. First, I wanted to talk about calibrating the ESCs. So let's spin up, this one is motor number 3, isn't it? Yep. So you can actually do this with the keyboard too. So I'm just raising the value in this slider with the keyboard arrow keys. And when I get to about 1028, it starts up. So it's reliably spinning by about 1035-ish. Sometimes when you get an ESC, it's not recognizing or it's not measuring that time pulse in the correct way. And it can also be that one of them will be okay and one of them will be not okay. And to make sure that they're all on the same page and they're all receiving those signals and measuring the timing correctly, we can do something called calibration, which is this second mode that was shown with these beeps. The way that we perform this calibration is by starting the ESCs up with the pulse, the instructions already at the full throttle value. So we can do that by using this master slider and just raise all of the values to 2000 before we start. And because this is being powered by USB, it kind of starts doing the calibration process already. But I've found that when you plug in the battery, it resets the ESCs and it starts all over again. So the best way to do it is with the battery. And what we're looking for is this sort of a doodle-it, doodle-it. Oh no, it's got to go up doodle-it, doodle-it, like that. Let me just do it. So that's those 3. So what that means is that it indicates that the max throttle value has been stored. So whenever the flight controller says 2000, then the ESC is going to recognize that as full throttle. And then to do the next part of it, we should hear some sets of double beeps, and then it should go down in pitch 3 times. And we'll do that by just putting the throttle or this master slider all the way down to the bottom. And then we're done. And then you should disconnect the ESC. And one way you can check that you calibrated everything properly is by using this master slider, and when you raise it up, the motors should all start at pretty much the same time. There shouldn't be any that start or they lag behind. And they should all sound like they're about the same speed. Let me just show you all of the motors together starting at the same time. So you should get something like that. Okay, so now the communication between the flight controller and the ESC should be all good, but we still have two motors. I think these two motors, wasn't it? No, these two. Yeah, these two motors were spinning the wrong way, so we can either desolder these and switch two of them over, which I'm not going to do. I like to keep it all nice and tidy the way it is. Or we can use BLHeli to do this for us. So let's, we have to disconnect from betaflight to do this because we're actually going to connect to the flight controller using BLHeli. So this is the BLHeli suite program. To get the BLHeli suite software, I don't think we looked at this earlier, so let's just do it now. If you search for BLHeli or BLHeli suite, it should be the first link, and then you go to that page and then this page, and you should have some files to download there. The one that you're going to want in most cases is this first one. The lower one, BLHeli Suite 32, is going to be applicable for more modern ESCs that have some more features that you can use, but I think the one at the top should work for any BLHeli supporting ESC. And for these particular ESCs, I'm using an Atmel. These King Kong ESCs are an Atmel CPU, so I would choose this one here, and it'll be the one that has clean flight in brackets afterwards, because I'm not connecting to the ESCs directly, I'm connecting to them through the flight controller, which is running a type of clean flight. So betaflight, as we saw before, is like a child project of clean flight. And if you're using a more modern ESC, you might find that it has a Scilabs bootloader. So in that case, you would choose this one. But for the ESCs that I have, I'm going to choose Atmel Clean Flight. And then if I click Connect, we don't see anything immediately. But if I click Read Setup, we should see something like this: found multiple ESCs in Atmel mode, and it will show us what firmware they have on them at the moment. And I can just click OK. ESC number 1 read successfully. So the stuff that we're looking at now is for ESC number 1, which is this one. And now we can make some changes. And one of the changes that we wanted to do was change the motor direction. So we're going to click this or slide it, or what does it say there? 1 is normal, 2 is reversed, 3 is bidirectional. So we want to make it reversed. And when we do that, we'll see some other icons showing up here that let us undo changes or restore it to the factory default value. So this is for ESC1, so I want to write that setup. And then it should say, oh, multiple ESC write successful. Whoops, did I just write that to all of them? Yeah, I think I did. So you can write these settings to all of the ESCs, was not what I wanted to do. And on this tab here, if we click ESC Overview, we can get a table or a spreadsheet, kind of a table view of what's going on. And it looks like I only reversed the motor direction for number 1, which is okay. That's what I wanted to do. So let me go back over here. Oh, I see. It's whichever ones are selected in blue. So let me click on number 4, because this is the other one I wanted to change. What are we doing here? Oh, I guess when we click it, we enable it, huh? Okay. So I'm going to enable number 4 and click Read Setup. This time we're reading setup for ESC number 4. And again, I want to change this to be reversed and then write setup. Alright, so I'll turn all of them back on and do read setup again. And then ESC overview. So what I'm hoping to see here is that for motors or ESCs number 1 and 4, I have reversed, and then motors 2 and 3, I have normal. So that's all I'm going to do here. If you want to, you can flash a newer version of the BLHeli firmware, and I'm not going to do that, but you may want to do that, and it will let you choose from a selection of more up-to-date ESC firmwares, and then you can do flash BLHeli to write it to these ESCs. But I'm not going to do that for now. So now if I go back to my Betaflight, oh whoops, so I need to disconnect from this now. you can't have both of these connected at the same time. So if I go back over to Betaflight and connect, now if I go to motors and I check motors number 1 and 4, let's check number 4 so you can see it. Now this one should be going clockwise. Check that, number 4. There we go. So when I try and poke this in, it gets pushed over to that way. And let me just check for motor number 1 as well. Yep. And the other two, hopefully they stayed the same. So now we've got everything working correctly. Yep, that's going counterclockwise. And this one should also be going counterclockwise. Good. So all the motor directions are correct. Alright, now it's time to connect up the receiver, and as we saw in the previous videos, there's 3 ways that we can do this, or 3 ways that we looked at anyway. One is to get a bunch of these and connect up lots and lots of pins on here and lots of pins on there, but we don't want to do that because that's kind of silly when we're only connecting 2 individual boards together. The other way we could do it is by this thing called PPM, which sends all of the pulses for all of the channels on one wire. And if we're going to do that, then we would connect this into that position there. And we would also need to tell the receiver that it should output PWM. So to do that, we would turn this on, and then we hold down OK to get to system setup. And we go down to RX setup, so this is receiver setup. And then second item on this menu, PPM output is off. So we would change that to on by using the up and down buttons there. And then to confirm it, we hold down the cancel button. And we should get the higher pitched beep. So that should now be outputting PPM on those pins. And on the flight controller side, we also have to make some settings to make sure that that will be used, or we have to tell the flight controller about it. And the way we do that is on the configuration page. Scroll down a little bit until you see this receiver section and change it from PWM, which I think was the default setting, change that to PPM RX input and save and reboot. And then the other end of this wire, as we saw, so let me just put this in here, and I can't show you the underside of this flight controller now, but I know from memory that these pins here are ground, 5 volts, and then receiver channel 1, which if you tell the flight controller that you're going to be using PPM, it will use pin number 1 to be the PPM input. So if I plug this in like that, my radio should suddenly detect that there is a receiver, and we should get a solid red LED on there. And if we go to the Betaflight configurator and we look at the receiver page, we should see some values showing up. And if I move my sticks around, I think we already looked at this, didn't we? But we should see roll, pitch, yaw, and then throttle, like that. Now raising the throttle is not going to do anything because the quadcopter is not armed. And did I put switches on here? Yes, I did. So probably the next thing we should do is look at how we can set up a switch, because I've already set these up, but to show you how to do it, we'll need to look at the menu on the radio again. Let's see if I can get this right. It is in the function setup, and then if you go to aux channels, so this is auxiliary channels, and I have channel 5 is switch C. So switch C is this one here, which is the 3-position switch, and switch D next to it, it's a bit hard to see, but that says switch D. This is the 2-position switch. So channel 6 is going to be switch D. And we can change those around by, I think, yeah, so press the up and down buttons to change them to something else. So you've got should have A, B, C, D, and then VR, A, and B are these dials here as well. So that's VR, A, and B. We probably don't need to use these for anything in this video series. You're probably just going to want to have a switch. So I'm just going to use this switch here for all of the flying that I'm doing in this video series. So that's switch D, and that is, what did I say that was? That's channel 6. Let me just put this back how I had it. Switch C. That's how I had it, wasn't it? Yeah. Alright, so channel 6 is switch D. That's the point that I'm trying to do here. So that's why when we looked at this and I flicked this switch, we see channel 6, which is aux 2 in this case. So the first 4 channels are always going to be your 4 control sticks, and then whatever comes after that will be your auxiliary channels. So channel 5 is auxiliary 1, channel 6 is auxiliary 2, and so on. Alright, so that's our radio ready to go, at least for PPM. What if we wanted to use iBus? That is going to take a little bit more setup, but not too much. And the way iBus works is, let's just look at the receiver again. So the receiver has on it iBus there, and this one here is servo. This is the outgoing information. So we want to connect that plug like this in that top section. Whoa, there we go. So it's going to go in the top section there, right at the top, and we're going to have the ground on the left and the signal pin on the right, like this. And this is the one that I'm actually going to use just because it actually lets me put this here and the plug doesn't get in the way of where I'm trying to position it. But of course we have everything else. We have the Betaflight is still using PPM, so we need to make sure that Betaflight knows that what we're going to do. So let's go to Betaflight and go back to the configuration page and go back down to this receiver option. Now the mode that we're going to use, or the type of communication, was a serial based receiver. So it's one of these, and when we select that we get some more options, and we also get this note: remember to configure a serial port via the ports tab and choose a serial provider. So the serial provider is there, but let's go to the ports tab first because we need to do this. And I'll try and keep this brief. We have some serial connections. So this flight controller has 2 serial connections that it can manage at one time. The first one is this UART1, and we do not touch that because this is the connection that the flight controller is currently using to talk to your computer over the USB cable. And this has to always be MSP. Don't touch it, because if you mess with that, you will not be able to connect to the flight controller and use Betaflight Configurator anymore. Don't touch it. Now this second one, UART2, this one we can change, and we want to turn this one on to be a serial receiver. So check this on and then do save and reboot. And now we can go back to configuration tab, and this time we'll actually save this setting. So choose serial based receiver again, and then for the FlySky radios it's iBus, and then we'll do save and reboot. So now Betaflight knows what's going on, and the connections for this are not quite as convenient. The pins are no longer, it's no longer going to be receiver channel 1, it's going to be channel 4. So my ground and my 5 volts need to go to the same place as they were just before, so I can use this plug as is, but I need to kind of separate the signal pin out and put that onto channel 4. So I'll just pull this out like that, and I'll tidy this up a little bit later, but just for now to show you that everything's working. So ground and 5 volts go on the same place, powering the receiver, and then this is going to go on to, so we've got 1, 2, 3, 4. So this goes on to there. Right, so that should be everything ready to go now. Let's hope that it worked. Let's go over to Betaflight and look at the receiver tab. And nope, it is not working. Let me see if I can figure out why that is. Oh, I see the problem. Did you see the problem there? I was counting these pins, starting from the one that's next to the triple plug, and I counted this pin as number 1. But this is actually number 2 because there's one inside the plug there with the set of 3. So that's 1, 2, 3. This one is pin 4. There. Alright, let's try that again. So we go to the receiver tab this time. Alright, we should see everything's going. So it's like that, and we have our switches ready, and it's all up and running. So that is the iBus connection. So once you've figured out whichever connection protocol you want to use, you can trim the channels so that when you let go of the stick, for this stick at least, pitch and roll, ideally this should be exactly on 1500, and you can do that with these trim buttons. So if I trim the roll value, roll should go up, which is the wrong way. I want to go this way. So I can set this to, oh come on, it doesn't go to 1500. What? That's a bit strange. Oh well, as close as you can get it to 1500 is what I'm trying to do there. And then pitch will be this one, like that, 1500. Yaw looks about right. That's okay. And then throttle, yeah, 1000. Good enough. And then finally, the last thing we need to do for the receiver is to set up flight mode. You don't strictly need to do this, but when you're just starting out flying, you probably want to fly in auto level mode. And the default behavior is not auto level mode. So to make sure that we do get into auto level mode when we're flying, let's come to this modes tab, and we have a bunch of modes here. So we've got arm, anti-gravity, angle, horizon, head free, and stuff like that. So I'm not going to explain all of these just now, but this mode here called angle mode is otherwise known as auto level, and it's not on at the moment, but we can make sure that we turn this on by clicking add range, and it's set to aux 1 at the moment, but if you remember from just before, this switch that I had here was set to aux 2. So let me just select aux 2 for this this option, and then we'll see that this little yellow marker, when I move the switch, now it's jumped over to here. Oh, sorry, you can't see that, can you? Let me just put this on the screen again. There we go. So the little yellow marker moved over to here, and when I flip the switch, it shows me it's changing between 1000 and 2000. And then I need to move this section here. I can make it wider and narrower as well. So I need to put this in the location that I want it to be to enable this mode. So for example, let's say that I want it to be, well, let's just say for example I want to use auto level mode all the time, and this might be the safest way for you to start out, so that you don't have to care about what position the switch is in. It'll just always be in auto level mode. So to do that, you would go like this and just stretch that span to cover the entire range, and then click save, and it should say at the top there EEPROM saved. By the way, you can expand this and hide it if you want to look at a little bit more of that information there. So in this configuration, no matter what you do with the switch, it will be in auto level mode. So this is a good safe way to start out, I would say. And if you actually want it to be, if you want to use the switch to change into acro mode or rate mode, let's see, how would I do it? Like that. I want to make it so that I'm just going to put it to the way that I'm used to, which is having it so that when the switch is up, let's see the little orange tab. So this is going to be angle mode is on, and when I switch the switch down, because my little yellow tab is outside the yellow range, it will be, angle mode will be off. So let's save that. And now, for this particular mode, you don't get this with every mode, but for angle mode you do get this confirmation. And by confirmation I mean when I flip this switch, we can see that the color of the cell changes. So that means that when my switch is up, angle mode is going to be enabled, and when my switch is down, angle mode is going to be disabled. So when you're starting out, you might just, like I say, want to have it enabled all the time, but if you want to try rate mode, then you could have it on a switch like this. And another confirmation you should see with this flight controller and this angle mode at least is when you change the mode, you should see this LED go on. So it looks like the red LED goes on when it's in angle mode, auto level mode, and it goes off when it's not. Okay, we've just about got this thing in a flyable situation now. I've put the receiver on the back like that, and I've just temporarily zip tied the antennas under here so they don't get into the propellers. This is a pretty terrible place to put them, but this is just for doing a few quick test flights. Should be okay. So the last thing I'm going to put on is one of these little 5-volt buzzers, and I just connected it to the other half of one of those servo cables that I cut in half before, and the positive side is the longer pin on this, and it also has a little plus mark on it as well. So this side here should go to the 5-volt pin on your flight controller, and it's going to go in here beside the battery sensor wire, just on the fourth from the left in there. And this one also has ground on the outside. So let's have a look at what we can do with this buzzer, and you'll notice that when we power it up it makes a little beeping noise just to say welcome, I think that one is, and then it'll make another set of 3 beeps when it finishes calibrating the gyroscope. The gyroscope is calibrated by just letting it sit still for a moment, so let's try that. There's another set of beeps that happened at the same time, so it's a bit confusing. So let me start it up, and this time I'll move it around so that it doesn't get a chance to calibrate the gyroscope. So it needs to know what it feels like to sit still. So let me just let it sit still now. So that set of 3 beeps means that the gyroscope is calibrated and you're ready to fly. Other things we can do is, you might have noticed we've got another beep when I switched the radio on. So when it went from having no radio to having radio, it beeps. And when I switch between angle mode and rate mode, it's going to beep as well. And if I hold the throttle down and yaw to the left and hold it there, it also beeps until I let that go. So that can be handy if you have lost the quadcopter in the long grass and you just want to make it beep to help you find it. You can do that, or actually what I do these days is I just do this. It works the same way. Oh yeah, there is one other feature of the buzzer that can be quite helpful. If you lose radio control so that you're unable to intentionally make it beep, it could be quite hard to find, but luckily if we turn the radio off, after a moment it will start buzzing on its own. So even if we can't control it to make it buzz, it will still help us to find where it is. Then we turn it back on, it will stop. Okay, so now that we have pretty much everything ready, we can test arming and disarming the quadcopter. So by default, the way that you arm the quadcopter, in other words, get it ready to fly, like if we raise the throttle now, nothing's going to happen. But to arm it, we push the stick all the way over to the right, and you'll hear a beep, or 2 beeps actually, and the motors will all start spinning. So this is one reason you don't want to have the propellers on when you're working on it at the desk, just in case you bump that stick like that. So yeah, arming and disarming. Arming and then to the left to disarm. And when it's armed, then we can try to fly. Now this situation that we've got here when the motors spin up when we arm it, this is the default behavior. But when you're just starting out, I might recommend changing this a little bit so that the motors, even when it's armed, they don't start spinning immediately, and you're required to actually raise the throttle a bit to get the motors to start spinning. And I like this because the very first time you try and fly the quad, the maiden flight, you might find that something's not set up properly, and it can be made worse by the fact that when you arm, the motors have a sudden kick to them when they start, and it can sort of exacerbate any problems you might have about not having the props on the right way or not having the gyro orientation correct or something like that. So I like to be able to just carefully raise the motor speed just for the first flight at least, just to do things a little bit more carefully. So back over in Betaflight, we can make a setting on the configuration tab, and in the upper right it is this little checkbox or this slider called motor stop. So if you turn that on and then save and reboot, now we'll find that when I arm the quad, the motors don't spin straight away. It's still armed, and we'll notice that it turns off after a moment. It turns off after 5 seconds actually. I don't like that either, so hang on. Let me change one more setting while I'm doing this. This one here, disarm motors after set delay. So after 5 seconds you might have heard the double beep, which means that it disarmed itself. So I like to give myself a little bit more time, 30 seconds or so, before it automatically disarms. So let me do that. Alright, so now when I arm, we'll get this occasional beep. So this is just sort of a warning to remind you that it is armed, and as soon as you bump the throttle, you're going to get the propellers spinning, just to be careful. And then to disarm is of course the same. So you get 2 beeps to disarm, and then a long beep and a short beep to arm. So now we can just sort of raise the throttle a little bit more carefully. So for the very first flight you might find this way of doing it a little bit easier. And another reason to perhaps do this when you're starting out is that if you're flying around and you panic, or you crash into something, or you hit the ground, or you're heading towards somewhere that you don't want to head towards, all you need to do to just shut everything down is to put the throttle down like that, and everything will shut down completely. The motors will stop. Whereas if you, in the default behavior that we saw before, even if you put the throttle down, it's not going to stop. You also have to do this disarming movement as well. So I find that when you are trying to focus on flying and all of your brain power is just sucked up by just having to balance these sticks and do the movements correctly, it's just one less thing to worry about, that if you suddenly panic, all you have to do is that. So I might suggest, for that reason, I might suggest to have this motor stop switch on for your first few flights at least. So now that we've got all that done, we are pretty much ready to take it outside and give it a test flight. Although we do need to figure out how batteries should be charged up and managed first. So that's probably going to be the topic of the next video. But anyway, this video is way too long already, so I'll just thank you for watching and leave it here. See ya.